right, in this first problem, we are asked to solve this system of equations. And you could do it by hand, but I think the much quicker way to do it is to use your calculator. What specifically on your calculator are you going to use? Matrix. So you're going to go to Edit Matrix. This is a 3x4 matrix, 3 rows by 4 columns. Then you'll edit and put all those numbers in there. Once you have it edited, then you're going to go to RREF, the reduced row echelon form, to figure out what X, Y, and Z are going to be equal to. And I know in this one that the answers come out to ugly decimals from the RREF, but if you hit math frac, it'll give you the fraction, the exact fraction equivalence. So again, edit, put it in there, RREF. It's an ugly decimal, try to turn it into a nicer fraction to get an exact value, and we can figure out the X, Y, and Z value of where these intersect each other. Check your numbers. Your form is wrong. You're only using one finger. You've got to use like all 5.
No. Yeah, I think it's like in the map right there. Yeah.
Question number 1 is this. Number 2, we're not going to full out do. Just find a cubic equation when given these following points. The reason we're not going to do it is because it's very repetitive of number 1. We're just going to talk about how you would get it started. This point is on that cubic. So we're going to plug -2 in for all of those x's. So it's a times -2 cubed. -2 cubed is -8, so it's -8a. Plug -2 in for the x, so -2 squared is 4, so it's plus 4b. Plug -2 in for the next one, so it's -2c plus d. And then notice I'm going to move the y value over to the other side, so it's equal to -27. So I'm going to plug that point in to get one line. But because there's 4 variables of a, b, c, and d, I would need to have 4 equations. That's why we have 4 points given to us. Then you plug in the other 3 points to get your other 3 equations. Go to calculator, RREF, and you'll get your solutions for a, b, c, and d. Okay, so that's the general idea. Because of our limited time, I don't want to spend a bunch of time on that. That's just how that one's going to work out. Number 3 is partial fraction decomposition. There were 2 special cases. There was the top-heavy one where you had to divide first. There was the one where you had repeated roots in the denominator, where if you factored it, you might have like x squared or x plus 5 quantity squared. That's not the case for this one. We can just straight go for the partial fraction decomposition. Factor that. About x plus 8 times x minus 3 is how it's going to factor. So this is the expression. This is what we're given. We're going to turn it into an equation. Instead of having this one big fraction with a squared denominator, we're going to say that we want to have this as some number over just this linear x plus 8 and some other number over the linear x minus 3. So we have this big equation. We want to figure out what a and b are equal to. And what I'd say for this math problem and a lot of other math problems and a lot of problems outside of math is identify what is the problem. Like, what is it about this one that we don't like? And then once you figured out that, then ask yourself, what do I need to do to take care of that problem so it's not there anymore? And in this one, we don't particularly like the fact that there are fractions, right? We don't like the fact that there's denominators in these. So to get rid of those denominators, we're going to multiply by what they are. Multiply everything on both sides by x plus 8. When you multiply the left side by x plus 8, gone. Oof. Multiply the first term on the right by x plus 8, denominator gone. We're solving this problem. We're making that problem go away. And then multiply the other one on the right by x plus 8. Unfortunately, that one won't simplify. We actually multiply the b times the x plus 8. We still have denominator of x minus 3, so multiply everything on both sides by x minus 3. Multiply it by the one on the left, denominator gone. The first one on the right has nothing to simplify with, so there's going to be an x minus 3 there. Multiply it by the last one on the right, x minus 3 gone. And we're left with just numerators, just what I have highlighted in yellow. So I'm going to rewrite that. 4x minus 23 is equal to, on the right, distribute ax minus 3a plus bx plus 8b. So we have this blue equation. And in this one equation we have, there's three variables. There is x, there's a, there's b, and we're supposed to solve for a and b. Here's where we use the idea that there are different components to this one. There is an x component on the left and the right. On the left, there are 4 of the x's. On the right, there are a plus b of those x's. So now the a plus b has to be equal to 4. Then there is the number component of this. On the left is negative 23. On the right is a negative 3a plus 8b. So that black system needs to be solved. There's now 2 equations and 2 variables a and b. We could use elimination or substitution if you think you're really proficient with that and you want to go that route. Not a bad idea. Or you'd rather go to your calculator and use matrices. That might be a quicker way for some of us, maybe more accurate as well. If you went to the matrices, you'd have 1, 1, 4, negative 3, 8, negative 23. Move those constants to the right side and RREF it. Do I have mine backwards? So 5 over x plus 8 minus 1 over x minus 3. Yeah. You can cross off number 4. Don't worry about that one. Go ahead and read number 5. Define your variables, a, b, and c, or x, y, and z. It's up to you. Stand for the amount at 3%, the amount at 5%, and the amount invested at 8%. We're going to define the variables. That's going to help us keep track of these different parts that we have. I've got one sentence highlighted in orange. Can you make an equation out of that? And I'll help guide you through some of that, but look at the important pieces of information in there. Do you know what variables are involved here? We're using an x, a y, and or a z. %5 is y, 8% is z. So there's an equation relating y and z with each other. And if I read that equation, which is bigger, the y or the z? Y. The 5% is 3 times bigger than the z, so y is 3 times bigger than the z. So in order for this to be equal to each other, what do we need to do to one of these sides to make them equal? Multiply by 3. Don't need to multiply the smaller one, which is z by 3. So y equals 3z. And then algebraically, I want to get it into the nice standard form. So on the left, there are already 0x. So we have to write that, but not a bad idea. Plus 1y minus 3z to bring it over to the left, and now it's equal to 0 on the right. So I want to get in that form because eventually, like the previous ones, we're going to use the matrices because why not? Next, blue. Go ahead and read it. And the blue one is comparing x and y. The 5% is 20,000 less than the amount in the 3% or the x. So in this equation, I'm comparing x and y. X is the bigger one, right? The smaller, like x is the bigger one. How are you going to make them equal to each other? Quick turn to your friend. What are you going to do to make these two equal to each other? Go. And there's two ways you can make it happen. I hear those conversations. Y is smaller by 20,000. So if I add 20,000 onto it, then it will be the same size as the x. As far as the standard form goes, then we have 1x minus y plus 0z. There's no z's in this equation equals 20,000. The last sentence I have highlighted in green talks about the weighted equation. Each one of them is worth a different amount, but the total amount that you made for these investments was $3,800. Can you write that equation? Once you have it, it should be in standard form right away. Then go to your calculator, RREF, see if you can figure out how much is each. And I've done this problem a few times today. I know the X, Y, and Z are all multiples of 10,000. They come out to really nice numbers. Spoiler alert. Is it 30,000 then 10,000. And so these were like the hopeful outcomes, and evidently this person got it. Otherwise, like you'd be a fool. Like, why would you take the 8% interest? You're going to make more money off it. But like usually the higher interest rate means there's a little more risk involved, so it might not happen. That's just like the hopeful or the expected income. But these are the amounts invested at those, and you got meets all those other criteria that we were given there. Keep in mind that when it is 3%, it's not 0.3, it's 0.03. All right, go and turn it over. Given this following series, 3 plus 8 plus 13 plus ... plus 123 equals 1,575. We have to do a few things. First of all, find a rule for a sub n. It's called a closed rule. It's not recursive like the one that keeps on going, like how to get from one term to the next. That is one of the formulas we're given. It's one of these. Looking at this a little bit closer, what kind of a series is this? How did you get from 3 to 8 and 8 to 13? What are they increasing by every time? 5. We say the common difference is 5. To get from one term to the next, we keep adding 5. What kind of series do we call it when we keep adding the same number over and over again? The arithmetic one. So a sub n is equal to this. A sub 1 plus n minus 1 times d. Common difference is 5. First term is 3. So can you write that formula for a sub n? And that's the first thing we're asked to find, a sub n. Then it says, find the closed rule, and then find n, the number of terms used to arrive at the sum. So we have our first term, our second term, our third term. This is the nth term. We want to know what term is that. Is that the 5th? Is it the 20th? Is it the 100th? We have to figure out what term number that is. So set the expression equal to 123 and solve for n. Figure out like what term number is this? All right, so n equals 25. We have that part done. Check. And then lastly, write the sum of this partial series in sigma notation. So the partial series means we're not finding an infinite number. We want to know, like, what is this sigma going to look like? Sigma n equals 1, because we're adding the first term, all the way up to the 25th term of 5n minus 2. And that's equal to the 1,575 that we were given. So 3-part answer. This is the third part. That's all because it's arithmetic. That's why we use these arithmetic formulas here. Number 2. Is this another arithmetic series? No. We're not adding the same thing. We added 12, but then we added 36. Instead, what kind is this one? Geometric. 54 divided by 18 is 3. 18 divided by 6 is 3. So there's a common ratio, and that common ratio is 3. The first term is 6. we want to write the closed rule. So in other words, what is the formula for a sub n? I'm going to use this. A sub n equals the first term times the ratio to the n minus 1. And I'd encourage you to put parentheses around that, especially if it's negative. But if I didn't put it in there, if I had 6 times 3 to the n minus 1, it almost looks like it's 63 to the n minus 1. It's okay to write it like this, but sometimes your dots are really small. It's hard to see. So again, I'd really encourage you to do the parentheses part of that one. So that is the closed rule. Now we're supposed to write it in sigma notation. So step 2. N equals 1, 2. Okay, so look at what we have up here. How many terms are there? Infinite. And it just keeps going and going and going. So in sigma notation, this represents this of 6 times 3 to the n minus 1. What would that add up to? So I found the first term plus the second term plus the third term and keep adding and adding and adding. What would that eventually sum to? Good reason why we're quiet, because we can't answer that. This is a geometric series. The common ratio is 3. Here's how we would try to find the sum of an infinite geometric series. But what must be true about the ratio? Less than 1. That'll make it converge, adding smaller and smaller numbers, and then eventually converge and get closer to an answer. Because this ratio is bigger than 3, this would be an infinite number. Like we couldn't actually find what it's equal to. Instead, the last part says, find the 13th partial sum. So instead of finding the sum of all the terms from 1 to infinity, just find the sum of the first 13. Back to the formula sheet. This will turn out to be a pretty big number. Equals the first term of 6, parentheses 1 minus 3 to the 13th over 1 minus 3. Joe, you got it? So that is the sum of the first 13 terms. Tessa. Kind of because like the 6 is taking care of that first term. So it's kind of like your minus 1 fitting in there. Number 3 and number 4 skip. We didn't get around to those, didn't have time. So cross off 3, cross off 4. And number 5, I'm changing. We have x minus 3y squared to the 20th. What is the coefficient on the term that has x to the nth, y to the 12th? I'm changing it by quite a bit. The previous ones had like 3 parts to them. This is just a 1-part question. What is the coefficient on the term that has x to the n? I don't know what n is equal to, but a y to the 12th. There is a formula on the formula sheet for this binomial theorem, and here it is. If you can make sense of that, awesome. What I will say, the advantage of having this formula is just looking at that part right there. Each term has one of these combinations in front of it. And those combinations we could get from Pascal's triangle. But in this problem that we're working on, because it's to the 20th power, we'd have to go down from row 0, 1, 2, 3, 4, all the way down to row 20. And I don't think anybody wants to do that. So remember that there is a combination out front. We're going to use our calculator for the combination. And then each of the terms are going to be taken to different powers. So this is going to be x to some power, negative 3y squared to some power, and then some combination out front. This is kind of the template for this one. And it all starts by figuring out the exponent on this negative 3y squared term. What does this exponent back here have to be? So that we get y to the 12th. 6. And if this is 6, then what's the exponent on the x? 14. Those are going to have to add up to 20 together. What number goes in front of the c? Biggest number, 20. Then we have two choices for the number after the c. What could it be? Could be 6 or it could be 14. And we have so much symmetry here, you can put either one of those numbers, they're going to equal to each other. Technically, 14 is the correct choice, but 6 is just as good. It's still going to get you the correct number, so there's nothing wrong with the 6 at all. On your calculator, do 20C14. Math, probability. How about the essential one? What's 20C14?
38760.
Okay. So there's that times x to the 14 times, and then negative 3y squared to the 6th. I know y squared to the 6th is y to the 12th. That's why we chose that number 6 there. The negative 3 to the 6th, if you're doing that on your calculator, make sure you have parentheses around the negative 3. Because a negative base to an even exponent should come out positive and not negative. So instead of parentheses, negative 3 to the 6th. $729. The question is actually asking, what is the coefficient on this term? So we got to do a little bit more multiplying, specifically multiply that 38,000 number and the 729 number. This is a perfect question for Julie. And there's our answer. Just ask for the coefficient. I don't have to put the things after it. That's the coefficient. So, know how to do this? Understand these little differences? Number 5, will it be on the final exam? Test is not blinking, which means it must be. Yes, okay, looks like more than likely. Number 3, partial fraction decomposition, will it be on the final exam? Probably, good chance. Then know how to use your calculator for solving systems of equations.